You know that feeling when you have a brilliant idea, but you just wish you could get the computer to do all the boring, repetitive work for you? Well, that's what programming is really all about. It's not just about writing code. It's about turning your ideas into actions. And this is your manual for learning how to do exactly that with Python.
All right, so I want you to think of yourself as the pilot and your computer as this incredibly powerful machine. The thing is, it's also very literal. It's not going to do a single thing until you give it crystal clear instructions. So in this explainer, we're handing you the pilot's manual, the language it understands, so you can finally take control and make it do some incredible things.
So how exactly does the pilot talk to the machine? Well, it always starts with an idea. You take that idea, you write it down as instructions in a Python program, and then the computer takes action. And to get there, we really only need to master 3 core skills you see at the bottom: making decisions with logic, repeating actions with loops, and organizing all our instructions with functions. That's our flight plan. Let's get into it. Okay, first things first. Before our machine can do anything really complex, it needs a memory. We have to teach it how to remember stuff, even simple little things, so it can use that information later on. You know, the easiest way to think about this is with named boxes. We can create a box, give it a name like age, and then just put a piece of information inside, like the number 25. In Python, we call this a variable. If you look at the code here, name equals Brandon. That's just putting the text Brandon into a box we've decided to call name. It's really that simple. So let's just make sure we've got this straight. A variable isn't the data itself. It's just a name, a label you create that points to a piece of data stored somewhere in the computer's memory. Think of it as your way of labeling information so you can easily find it and use it again later. Now, these boxes are actually designed to hold different types of information. You've got your int for whole numbers, float for numbers with decimals, bool for simple true or false values, and str, or strings, for any kind of text. And knowing the type is absolutely crucial because, you can't do math with text. Okay, this is where it starts to get really interesting because now we can actually have a conversation with the machine. The input command lets the program pause and ask the user for information. But, and this is super important, there's a catch. You can see it in the diagram. Input always gives you back text. So if you ask for an age, you get the text 42, not the number. You have to explicitly convert it into an integer, a process we call typecasting, before you can do any math with it. All right, so our machine can now remember things. The next step in our pilot training is to teach it how to think, or at least how to make decisions based on the information it's storing. All the complex decisions a computer makes really just boil down to simple true or false questions. Is x greater than 5? Yep, true. Is x exactly equal to 10? Also true. Is x not equal to 3? That's true too. This binary yes or no logic, it's the entire foundation for how a program chooses which path to take. And this slide just illustrates perfectly how we use that logic. We create a path for the machine using if, elif, which is just short for else if, and else. So the computer checks the first condition, is the score 90 or higher? If it's a yes, it prints A and its job is done. If it's a no, it just moves on to the next question, and then the next, until it either finds a condition that's true or it just hits the else at the bottom as a fallback. It's basically a decision tree. And this whole structure, this if, elif, else block we've been looking at, well, it actually has a name. It's called a conditional statement, and it's one of the most fundamental tools you have for controlling the flow of your program. So, we've taught our machine to remember and to decide. Now, let's give it a superpower, the ability to do a task hundreds, even thousands of times without ever getting tired or making a single mistake. This is the power of loops. First up, we've got the for loop. This is your go-to tool for when you know the exact number of repetitions you need ahead of time. You can tell it, hey, loop through numbers 1 to 5, or tell it to go through every single item in a list, like this list of colors. It's definite and it's predictable. But what if you don't know when to stop? Well, that's exactly what a while loop is for. This diagram shows it perfectly. As long as the password is not let me in, the loop is just going to keep asking. It repeats indefinitely while a condition is true, and it only breaks out once that condition finally becomes false. Okay, so let's put these side by side, because this is the crucial difference. The for loop on the left, it's like a set of stairs. You know exactly how many steps you need to take to get to the finish line. The while loop on the right is different. It's like you're walking in a circle until you finally find the right key to unlock the gate. One is for a known count, the other is for an unknown condition. So now we have all the core components. But just writing everything in one long list of commands, man, That gets messy, and it gets messy fast. The next level of being a great pilot is learning how to organize your instructions into these clean, reusable blocks. A function is like teaching the machine a new skill and then giving that skill a name. Right here, we've taught it how to calculate the area of a rectangle. Now, anytime we need that calculation, we don't have to rewrite the logic. We just call the skill by its name, area underscore of underscore rectangle, give it the inputs it needs, and it gives us the result right back. It's so much more efficient and organized.
Now let's take that one step further. What if you want to bundle not just the skills, but the data with the skills all together? That's what a class is. And this slide has the perfect analogy. The class is the blueprint for a student ID. The object is the actual physical ID card you create from that plan, with specific data filled in, like a name and a major. You've essentially created your own custom data type.
And this is where it all comes together. The bank account class is a blueprint that holds data, like the balance, and has skills, like deposit and withdraw. We then create an actual account from that blueprint and use our other tools to interact with it. This is how all those pieces, variables, conditions, loops, and functions, combine to build a real working application. You now have the operator's manual. You understand the fundamental commands to pilot the machine. So what's the next mission? Your training isn't just about watching, it's about doing. This practice path gives you a really clear set of missions. Start simple. Build a program that just echoes back what you type. Then level up to a calculator. Then a grade classifier that uses those if statements. Each step builds on the last, locking in your skills until you're ready to build your own mini app from scratch. So, we've handed you the keys to the machine. You have the manual, you have the flight plan, and you have your first set of missions. The only question left is the one that really matters. You're the pilot now. What idea are you going to bring to life first?